TeacherMeetUp.com for help with introductory statistics teaching. And so I will quickly talk a little bit about my philosophy behind those apps, but then fairly quickly go over some screenshots of the apps, mention what they all can do, and then I want to just showcase 2 or 3 of them, and leaving though plenty of time for you to ask questions specifically about certain apps you might have questions about. So the motivation behind my apps, and as always, please feel free to interrupt me by just raising your hand. I have some of you in view, or just interrupting me. The motivation behind those apps is I want to really, it's twofold. I want to illustrate concepts, statistical concepts, and I'll show one of them, such as, typical ones are a coverage rate of confidence intervals. What does that mean? Or the central limit theorem, or sampling distributions in general. So those concepts, to illustrate them, that's what typical apps are for and have long been around. But I also want those apps to carry out statistical analysis. So really doing the statistics, both the exploratory and the inferential part of statistics. Now, I also wanted those apps to be easy accessible. And the best, I think, that our best way to now access content is just through a web browser. So these apps all run in a web browser. There's no installation necessary, there's no download necessary. It should work on all platforms and most devices. So you can also connect them on, or open them on tablets. Smartphones are not ideal because the screen size is kind of small, but technically they work on any device that's connected to the internet. Now, the other thing is, the motivation behind those apps is I wanted them to be interactive. That means the user has to interact with the app to show stuff, to explore things, such as moving sliders around or downloading graphs to include in homework and those kinds of things. I think they should replace calculators. I do think now we have better things than those statistical calculators that we're using, especially in K to 12. And I hope they serve at least as a complement to those. And the whole suite of apps that I've been creating should be a one-stop shop for all your needs in introductory statistics. At least that's what I am envisioning it. And I fairly do get through a whole course of introductory statistics just using those apps and nothing else. So it's a one-stop shop for all your statistical computing needs and illustration needs. The slogan would be great, right? There's an app for that. For every concept or for every analysis you're going to run in your intro statistics course, there should be an app for it. That's sort of opposed to, when you have commercial packages, they open up in one big screen and you have to first find your way around. Well, how do I get to a specific analysis, or how do I do a specific graph? You have to dig down the menus. The philosophy is different. There's just an app for a specific task, and the app does that task, but nothing else. Now, the other motivations, of course, is to move away from generic computer outputs like you see on the left in your screen. I took the screenshot from Stata because the intro stats course I have to teach right now has to use Stata to prepare economic students for the econometrics class. But I want to move away from them, at least initially, and show them something more comprehensive where everything is in place. Like we have a graph, you see this in the upper right corner. It's kind of small, but there's a graph in the upper right corner. Everything is nicely labeled. There's no shortcuts. Even sample standard deviation is spelled out and not just called S, because students always forget what S is. So I write things out. This is about a confidence interval, for instance, this particular app. So there's a nice illustration of a confidence interval instead of, if you look at the computer output, it's somewhere in here. There's a confidence interval which you have to search for. And so everything is in place. And there are sliders, for instance, here on the upper lower part. When you want to change the confidence level, you can do so by just moving a slider. This is a thing, I took this from the TI calculators, these outputs here, about finding quantiles for normal distributions, right? This is very hard for students to understand. And why not visualize what they're searching for to avoid errors and for them to see what they really are computing? So those are kind of motivations behind those apps. The goals I'm having is, the bullet point here says playing and exploring. I think a more modern term now is gamifying. I want to gamify a little bit our introductory statistics classes. And gamifying really means learning. And it often means learning by trial and error. You just try something out. What happens if I take that slider for the confidence interval? What happens to the width? And as you take it, the student sees what's going to happen to the width of a confidence interval as you change the confidence level and so forth. So a trial and error approach that I think supports learning. And of course, the apps are heavily designed with the visualization in mind. I want to visualize as much as possible as I can concepts or just statistical analysis. And finally, right, I want to supply access to modern statistical methods for everyone. And by modern, those apps, or there are certain apps that even can do resampling, which you need a computer for, resampling approaches to inference. And so there should be access for that as well. And the apps provide, at least for some basic resampling procedures, provide such access. So that was a just quick tour of what motivates me to develop those apps. Let's just look at some examples. I'm going to start one with about alligators. You're going to see me talk about two things, alligators and sharks today. Those are memorable. That's actually a picture I took a long time ago. And here's a data set that, I don't know, did I see Ellen in this call? We are very familiar with. This is about the food choice, the primary food choice of alligators. They were caught in various lakes, which you see here in the data set. I think there's 4 or 5 lakes. Those are lakes in Florida, by the way. Their gender was determined, their size, here it was just binary, less than 2.3 meters or bigger than 2.3 meters. And then this is the response variable, their primary food choice, which was determined by inspecting what they have eaten. And that could be one of several categories, fish, which we'll see is the most common category, or they eat birds, they might eat invertebrates, or even something that's classified as other.
Bring it here.
And so that's a very basic data set, right? You want to visualize what's going on there. Maybe you just want to find a bar chart of the primary food choice. And how do you do this with the app? You would go to the artofstat.com website, and that looks like this now. It's just a new look. I just had to program a new web app. And then you could click right there on web apps here, or in the menu down here, just click on web apps. And that will bring you to a whole list. And we'll go live and do this in 5 minutes. Whole list of possible apps. They are grouped somewhat by topic. I call them exploratory data analysis tools. And then for getting a bar chart, we are exploring categorical data. And so this is what I want students to think. Oh, we have a categorical response variable, primary food choice, with 4 or 5 different categories. How do we show its distribution? Well, that's a categorical response. So I go to explore categorical data, and not, for instance, go to explore quantitative data, where I'll have trouble exploring that data set. So then the student will just click on that app, and I'll show you in a minute what the app will do. The apps are sort of grouped by topic. There's a bunch of tools for exploratory data analysis that mostly plots. There's some random number generations here too, and some concepts, mean versus median. But there are other topic groups, such as association more generally, or correlation and regression, with lots of different apps. And I hope to have time to show you the multivariate relationship apps. This is, maybe Chris, you want to put a plug. I just read your new guidelines that came out not too long ago, the ASAK guidelines on K-12 statistics education. And one big point I think, Chris, you make in there is to talk more about multivariate relationships. Is that correct?
Definitely, we're emphasizing it all the way down to middle school.
Right. And I think, you're probably not going to run multiple regression at that level, but at least you can look at scatter plots and maybe color dots, different colors, to explore multivariate relationships. And that app, for instance, is designed to do just that. Other apps have just basic, as I mentioned before, basic distributions, how to visualize them nicely, how to get probabilities or quantiles for various basic distributions. And those charts are also interactive. Like they always have an explore tab where, what happens if you take the slider for the mean mu for a normal distribution? What happens to the normal distribution? Well, if you take the slider to the right, the normal distribution shifts to the right. Or what happens if you take the slider for the standard deviation sigma? The distribution stretches out or narrows down as you move that slider. So that's an easy way for students to understand what those 2 parameters mean for the normal distribution. There are apps that explore more concepts, particularly here about sampling distributions for proportions and means. I don't know if you have time to do that. I didn't plan. Well, maybe we'll see one of them where you ask about one of these. And then there are apps about inference. These are just basic inference for a single proportion, for a single mean, and then concepts like what does it mean? What does coverage mean really? Or what's the relationship between type 1 and type 2 error, and so forth. All right, let's maybe go into one app specifically. I did show you the data set on Alligator food choice, and that's one that's actually pre-implemented with the app. So when you open the app, this is the screen you will get, and it has the data set preloaded. It shows a table here, and then shows a basic frequency table. So you can talk to your students about, the frequency and then the proportions and the percentage to describe the distribution. And then you can go to the bar chart that's given here automatically. This is actually an interactive one. You can hover over a bar, and then this thing will pop up. It'll show which category you're referring to, the number of observation in that category, and then the percent of observation in that category. And all these apps are designed similarly, that you have what I call a user interface on the left side, where you can do lots of stuff. For instance, I could click on show a percentage or show percent, and then instead of counts, I'll plot percentages on the y-axis. I can do a Pareto chart that will sort the categories from most frequent to least frequent. I can plot horizontal bars by clicking on this option, and so forth. So there's various things students can explore. And of course, they can give their own titles and subtitles and captions, and select even colors if they want to for the bars. Others are, there's the Explore Quantitative Data app. I just briefly show a data set about unemployment rates in the European Union. All these countries, the total unemployment rate. This is for a youth unemployment rate. So this goes only up to, I think, 25 years, the unemployment rate. And this was a couple of years ago, so quite high, especially in, let's say, Spain and Greece. And I break it down for males and females. So to explore that data, which is quantitative now, the unemployment rate, I would click on the Explore Quantitative Data app, and then I can get graphs like this by default. And again, this is something that's a data set that's pre-loaded. Although when you click on here, you can upload your own or enter actually your own data in here. So this would show a histogram of the unemployment rate with the box plot underneath. And that's nice, because then you can talk about both of those graphs simultaneously. You have options to change the bin width here with a slider. You can again display percentage on the y-axis. You can just select where the bins should start. And that's just good to explore interactively, especially the bin size, as we know, has often a huge impact on how we visualize the shape of the distribution. Other examples are, if you go to the same app, but several groups, then you can do side-by-side box plots or side-by-side histograms or side-by-side dot plots. Again, you can enter your own data, and you can select how many you want. Some are pre-implemented, but this is a side-by-side box. And maybe I just want to point out that example here. This is about a data set on the average SAT scores for each state. So there should be, I think, 50 observations in here. And then the participation rate of the SAT exam is rated as either low participation rate, medium participation rate, or high participation rate. And I'm showing now, so each state is going to fall in one of those three categories. Either state has low participation rate for the SAT, medium, or high participation rate in the SAT. And quite interesting is how the average SAT score, this is the score per state, differs between those states who have low participation, those states who have medium participation, or those states who have high participation. And again, those are interactive. You can sort of hover over those box plots. Statistics will show up. The 5-number summary in particular will show up if you hover over the box plots. And you see summary statistics. A couple of other graphs that I want to maybe just highlight, or apps. There's one that I like, I always introduce when I start talking about linear regression. When you start up this app, the Explore Linear Regression app, you see an empty scatter plot, and then you can just click, as I did here. You click in the scatter plot to create those dots, and then you can, for instance, select show the regression line, and then you can create an outlier by clicking and see how the regression line moves as you generated the outlier. But then you can click on the outlier again on that dot that will remove the point from the scatter plot, and you can visually observe how the line of best fit, how the regression line will change. And there's a couple of other options you can do here. So nice an interactive way for students to explore outliers, or even just to explore linear regression and what it means. Now, here's one. I don't know if I have time, but here's a great example that I like to use in my teaching. When it's time to teach about sampling distribution for the sample proportion, I ask, or I assume that in a certain student population or among a certain student body, 60% support a certain measure. Here, suppose a measure of changing the honor code. Suppose there's 60% support in the population. But as we know, as students are asked to vote on such a change, on such a proposition, not many may show up to vote. So maybe only 30 students show up, right? Participation in those surveys might be very low. And then I ask, well, what are the chances that that motion doesn't even pass when only 30 show up? And you can explore with that app, what are the possible sample proportions you can get from a sample of size 30 when the true population proportion is 60%. And there's quite interesting facts that, well, there's actually quite a good chance that the motion to change the honor code might not pass, although it does have 60% in the entire student body. And yes, you can solve that problem later with the binomial distribution, and you can go to that, and there's an app for that as well. All right, so well, actually, here's a screenshot. So I set the population, I don't know how well this comes out on your screens. I set the population proportion to 60%, 0.6 here. I set the sample size to 30, all the sliders. And then this would just show up this graph. So this would be the population distribution showing 60% support. And I could label this one by providing labels. I could say this, label this one like in favor, and this 0 here, not in favor of the motion. And then by clicking here, by draw samples, I can draw samples of size 30 from that population. And we have seen those apps, I think. There's just others around too. And they show, right, the sampling distribution of what types of proportions can come up. And we see a good chunk comes to lie below 0.5. Those would be proportions then the measure would not pass. And you can even, oops, sorry, you can figure out, I don't know, that's maybe too small to read. You can figure out how likely, what proportion of your simulations, here I use just 1,000, I should use many more, maybe 10,000. What proportions of your simulations had sample proportions less than 50% or at or less than 50%? And that will then be the chances that the motion actually doesn't pass. And then of course, you can take the slider for n and just slowly move it higher and see how increasing the sample size changes the sampling distribution, what the effect is. There's apps for inferences for means. I'm not going to read through this one, but here's an activity you might want to do with your class. And then I would pull out, I'll go through that activity and then click on the inference for a mean app, enter the data that we collected live in class, and then do various inferences about the mean. And so before I go, and I want to show you some live. So I thought that the philosophy I'm having is that each web app should focus on a particular concept and an inferential task, and it should be holistic. Like we always say, well, check the assumptions with the graph. That graph should be there for you to check the assumptions. Let's say when you're constructing a confidence interval. And so each app just focuses on one task, but I hope that task is done well, has everything in one place. Now, there's a couple of things I still want to add and work on. There should be help tabs that describe the app, what they're doing, and I'm working on that one, as well as maybe short videos, and I'm working on those. I'm actually now started a YouTube channel. I had to learn how to do that one, where I demonstrate some of these apps in action. And so I encourage you to go there if you want to know more and see me interacting with the apps, maybe explaining a particular concept. All right, I'm going to go, maybe stop here for questions, but what I would plan on, I need to check the time. All right, I'm doing fine. Maybe the next 10 minutes, just showcase 2 or 3 apps live in my browser. And then I really want to open it up and see if you have any questions. But let me pause here and see, do you have any questions right now? And I saw there's something in the chat, so maybe I should check that one.
Yeah, Bernhard, there were a couple of questions in the chat. One was, can you show the sum of squares within the Regression app?
Yeah, I thought about that. Not yet. You can show it, well, as a statistic, but not visually. Like I've seen those apps where you make the squares. I didn't find them too helpful, to be honest, but this is mostly, I think, to explain the concept of least squares, what least squares does. But so no, right now you cannot show the sums of squares You do get there's an app called linear regression. You do get the residual sum of squares as an output, right? As the estimator for sigma or sigma squared. That definitely is displayed. So the summary statistics, the residual sum of squares, that's given as a statistic, but there's no visualization of it.
Another question is, when you enter your own data, is there a limit on the amount of data that you can enter?
No, there should not be any limit. I have apps that actually have, I think, close to 30,000 rows in it, like that have data sets of 30,000 rows. When I'm demonstrating, I'm a huge proponent, when you demonstrate the central limit theorem, use real population distributions. And so I have some, one is, for instance, all soccer players, all male, I should say, all male soccer players ever registered with FIFA, which is the soccer governing body. And there's tons of them. And I have data on, let's say, the height on all of them. And so that's my true population distribution. Or I think I have a data set, this is really in the millions now, on yellow cab, New York City, right? How far the taxi rode on a particular day in New York City. And that's very long. And those apps seem to take those okay. So no, there is really no limit. Sometimes there might be a limit if there's a grid, and that was part in programming these apps, to get this Excel-like feature where you can enter your own data. That's sometimes a little bit finicky. There might be some limits there, but typically there's not. And many apps allow you to actually upload your own data set, your own .csv file.
Another question was, if you have a chance, or maybe you can talk about it, the ease with which you can copy and paste data into the applets.
That's actually a good point. I will try to show this right away. Yes, maybe, can I address this right now? Let's see. So I have, I don't know if you see, I need to share my screen now again, share. So I have an Excel spreadsheet open on my desktop. This is the one I showed you, the data set about the youth unemployment rate. And so, right, this is just for different EU countries. I could just grab that from my Excel spreadsheet. I press Control copy, right? I'm copying this one. And now I will go over, this means I have to stop sharing and go over to my browser. So I'm going to the browser. I'm going to artofstat.com. I'm clicking on web apps. And then if I want to explore the distribution of youth unemployment rate in the in the EU, this is explore quantitative data. I would just click on that app, and then it should open up like this one. And since I want to enter my own data, remember I would have to specify what the response variable. So maybe I should type in youth unemployment. Give it a name, and then really just I'm pasting in now. You don't see this, of course, but I'm just pressing Control V on my Windows machine. I'm pasting in the data, and here they are. And you can scroll through, and you can add or remove some if you don't like them. And like this is what I showed, right? We see a histogram showing up and a box plot showing up. You can hover over the box plot to see the 5-number summary. You can now, maybe if you want to, change the bin width interactively and see how that looks. If you don't like counts on the y-axis, although here with small data set, only 28 observations, maybe percent is not the best one, but you can change that one. You can, right, select colors. This is something you can just play around with if you want to. So yes, so it's pretty easy to just go to switch between the Excel spreadsheet, copy and paste from there, and copy it into the apps. And that's true for many of these apps. It would actually be true for the Explorer categorical data. Let me see if I can answer questions right away.
See, Bernhard, the apps are in R Shiny, correct?
Yes, those apps are all programmed in R Shiny. Yes, they are. I'm just seeing, so for I think Scott asked about uploading. Yes, so I do expect a .csv file to upload, but yeah, you got to sometimes be careful that you actually have commas delimiters. So you should, in Excel, save your data as a .csv, and then you should be able to upload it to some of the apps, like the linear regression app or some other of the apps.
I think that was the only issue, Bernhard, was that if it's in Excel and you're looking at it and you see that Excel is formatted to have the comma on the screen, it's not part of the number, but when you copy it, it brings the comma along for the ride.
I see. And then,
And then all of a sudden you're really large data values. We were doing the Flint water data, and it would take the value of 2,540 as the lead level, and it made it 2 and a different reading of 540, which is, of course, drastically different. Yeah. So just be careful with that. You can reformat.
I would, yes, suggest reformatting in Excel to get rid of the 1,000 separators. Yes, no, those are certainly issues. You're right. The comma would be an issue sometimes. All right, maybe let me demonstrate one app that I particularly like, because I mentioned it and I call out Chris about multivariate relationships. Mm-hmm. So I'm going to do that one and then maybe take more of your questions. So I'm going to scroll all the way down of those apps until I see multivariate relationships. And I want to do this because I brought along some, I don't know if you see this. Well, let me make my screen really big. Do you see what I'm holding into the camera right now?
Shark teeth?
Yeah, those are shark teeth, which I know a beach where I find them, and that's one of my hobbies. So those are fossilized shark teeth. They're millions of years old. I don't know if you see them. They look like this. And so I found a data set on fossilized shark teeth. What's interesting about sharks, especially those that are extinct, while their teeth are, because they produce so many, are plenty, those are easy to find, or those are fossils you can find fairly commonly. Shark skeletons are very hard to find. And so let me go back to, where's my, in the right one? No. Can you see, did I? Oh, this might be, I need to, give me a second. I just noticed a mistake on my new website. This should not link to the random numbers app. This should link to the multivariate. Oh my God, how can I? Oh, I know. I still have the old website there. Give me a second. I just saw I forgot to transfer a link. That's a glitch I need to fix, but there is the old website still there. And this is web apps. I need to take that website down because of security concerns. This should give the right link. So this links to the multivariate relationship app. And in there is a data set on sharks. And what they did is they went to a couple of museums where they have the tooth of the shark, but also the skeleton of the shark. And so this is in the fossilized sharks data set. And they don't have much observations. So here are the observations, a couple of sharks here that you see in the data set here. And what I'm plotting here in the scatter plot is the tooth length. So these are, that's that tooth, although these are all bigger sharks. So this is in centimeters. Well, some might not be. So those are 2 or 3 centimeters, almost what I have here in my hand. But they can go up to, a couple of sharks actually have really large tooth, up to maybe 35 centimeters. And I'm looking, and what the researchers want to know is, how does the tooth length that you find for the fossilized shark, how does it relate to the body length of the shark? And they had really no idea. They don't know much about body length. They would try often to predict that. And if you look at this scatter plot, well, there's one observation that's really weird. And a nice thing about these apps is you can hover, and again, that's interactivity. You can hover over a point, and then it links, right? It's highlighted in the data set to the left, and you can choose the information to display. You can display more if you want to display the sex, which is nothing I'm plotting on this. You can hover over now and see that's actually it was a male shark. So you can see that in information there. But maybe the relationship looks kind of nondescript. And then this is where I think we should start teaching multivariate relationships. One easy way is maybe to just color the dots a different color, and maybe maybe you think by sex first. All right, let's color them by sex, and then you see this one. So there's a bunch of that are unknown. That's why you see 3 categories here. But that didn't really help much. And so maybe you want to color them by their genus. And then you really get an interesting picture. And that's where multivariate relationships come in. It seems like, right, there's all these sharks with that gene, I don't know how to pronounce it, Alopius. genus, they seem to have a nice relationship that's though distinct from maybe the other geni. And on top of that, you can, and this is the nice thing about interaction and apps, you can hover over this point and see, well, this actually also belongs, right? It's also a red dot, belongs to that same genus, but it's actually a different species. So all these are one species, Vulpinus, and this one is a different species, which you might see when you hover over those points. And so now you uncovered additional structure in the data. And that's how I would, teach just multivariate thinking maybe at the high school level. So that's something I want to demonstrate. Maybe because you're all teachers, there are some really interesting data sets. Those are fairly well known, although I have a new one now. This is 2016 data. It's very interesting. It's going to be interesting for you teachers. Plotting, again, this is talking about SAT scores per state. So here are all the states, the SAT score in that column. And then I carried other variables. I measured average teacher salary. And some of you might have seen that data set, the one from 1996, because when it was written about, I think in the Washington Post about it, there were some wrong conclusions drawn. But if you just plot average teacher salary, or you could change this, and again, this is nice interactive, you can change this to maybe you want to plot expenditure per student on the x-axis, plot either of those against average SAT scores, and then you think of, well, let's look at a regression line. It actually comes out a little bit of negative, and you can overlay a smooth trend to see if regression is even feasible. But there also seems to be a small trend in there, namely that the higher the average expenditure per student, the lower the average SAT score, which kind of is weird, right? That's not what we would expect if I had asked you before what the relationship would be. And so again, what's nice here is you can then say, well, let's think about confounders. And now maybe I showed you a graph earlier on what would be nice to color the dots by. There are certain other variables I'm presenting in that data set. The region, for instance, and those are just which region in the United States, but there's one, well, maybe one of you want to speculate what I should choose as a grouping variable to better understand that apparent negative relationship between student expenditure, and actually the same happens if you plot average teacher salary. Where's that? Teacher salary against SAT score. Let me see if I can monitor the chat. Participation rate, yes, participation rate. Let's do that one. I sort of gave you a clue, but you have to think hard about that. That's not completely obvious. So if I now put in, let me first switch off regression. Let's color the dots in terms of participation rate, either percent, or I just call it SAT participation, which it's really a percentage, but I grouped them as low, medium, or high, as I showed you on the other chart. And if you explore that scatter plot now, you can even double click on just low, then it will just show the low ones. And now there doesn't seem to be any relationship anymore, right? That's completely gone. That seems pretty haphazard to me. Or if you want to go and just highlight all the medium ones, well, this is the medium ones. What was interesting to see that all those states with medium participation have much lower average SAT scores than all those with low participation. They just tend to be higher. But the relationship with average teacher salary is completely gone. Right? If you show that scatter plot, one of these, clicking on a legend, right? There's no relationship anymore. And so those are just nice things to show interactively. You can fit separate regression lines if you want to, and you see if there is a relationship, and there really isn't, it might actually be positive. Maybe in those for teacher which have high SAT participation rates. And if you want to know about, which are those states, you can again hover over and see what state each dot corresponds to. All right, well, let's see. There's a couple in the chat. Maybe I should address those first. Yeah, this is the Simpson's paradox really for continuous data. It actually is, if you want to be precise, there is a reversal in the direction of the relationship. If we ignore participation, we have you can actually display the correlation coefficient, I think. We have a negative correlation, negative 0.37, right? That's the negative correlation coefficient. Sure, it doesn't seem like it's perfectly linear here, but negative correlation coefficient. Yet when we adjust for the participation, we do see all the correlation coefficients within each group are positive. And the one actually between the high group is actually pretty high R, pretty high Pearson correlation coefficient here. So yes, that's Simpson paradoxes for continuous data, certainly, yes. Let me see if there's anything else in the chat I'm missing. Yes, good question. If you select participation percent, which is, then it will actually use a color scale. So if you select the percentage, we're not using my artificial grouping, it will actually color the dots by this color scale here. And again, you can see the dark colors are in the upper left corner and the lighter colors tend to be in the lower left, or really just in the lower part of the plot. So yes, you can do that too. Sure, you can go if you want to show actually the linear regression equation. Here you can fit the linear regression model, a multiple one, but I doubt you'll go there. I don't know, maybe you do in your courses. All right, maybe one more thing and then I'll turn it over to you. Maybe a different app. Let me cross out these ones and talk about, so go to web apps here. And I want to do one more about a concept maybe, and maybe I'll showcase the one I mentioned about the sampling distribution for the sample proportion, where I have, let's suppose 60% in the population are in favor of something. So if I want to label this, you can label this not, or just oppose, maybe. Oppose.
Bernhard, now that you're back on that one, the question was raised in the chat box about, are you assuming a random sample when you talk about the students of size 30?
Yes, yes, yes. I am assuming a random sample here. Definitely, yes, yes. Which, when I bring this back to the example I gave, who shows up for, elections at high schools about the honor code? Who knows if those showing up are a random sample of all students? Mm-hmm. Maybe those motivated to show up are more likely to actually, cast their vote about honor code than those who don't. But yes, no, I have to assume a random sample, yes. Otherwise, we wouldn't be able to do much. So oppose here for failure and favor, right, against the change to the honor code. I can label them, so it's a little bit more obvious. And then you can start drawing samples by clicking the draw sample button. And for this particular sample I left the size at 50. Maybe let's put it to 30, as I had in the example here. And you can reset if you want to. So you draw one sample, in that sample of size 30, we had 16 successes, 16 voting in favor for a sample proportion of 0.53. And so it marks the 0.53 here. And then in class, I would just keep on clicking and point out the very important fact that, look, in this plot, how the sample proportion varies. This is explaining variability, right? Variability of a statistic, how it varies around the true proportion. That's clearly, you can see that clearly, how it varies. Sometimes it's equal, sometimes it's less, sometimes it's higher. It varies, and it doesn't stray too far from it, or sometimes it might, or sometimes it's not. So this last plot here does keep track of the frequency of how often each particular sample proportion was observed. And then if you've done clicking multiple times, you can speed up by simulating 1,000 or maybe even 10,000 at once. And you do see the entire sampling distribution for that proportion. And you can see now here, well, there are cases in these 11,000 simulations where we did get a sample proportion of 0.5 or lower, right? So it's totally possible that the motion might not pass, although it does have 60% support in the population. Now, what happens if more people show up? Then I will grab the slider for N here and then slowly move it up, and then this graph updates, and you can see, well, two things: how the shape of the distribution looks more and more like a normal distribution, and how the variability of the sampling distribution shrinks. And so, for instance, if 100 people show up, then right, those proportions being less than 50% are much smaller chance. And if you want to go even higher, if you suppose 1,000 show up, right, then oops, then you get, and that's one downside of those apps. Sometimes you get these little things here. You have to adjust the screen size to make it a little bit nicer, then, and I need to work on this, you see a normal distribution, though you can actually zoom in. That's what I would show. You can zoom in on the x-axis because now we are very small, and then you can actually see the normal shape right here. All right, let me stop there and see.
Bernhard, before you move from that one.
Okay, yeah, I see the comments there. I'm not going to model the one from Georgia. And it's not a binary choice, really, right?
Chris, you were muted. We didn't hear you.
Let me get this pulled.
It is a binary choice, actually, in each race.
It is, right? I forgot. Yes. There's just only two. I didn't follow that, actually. There's only two for the runoff, the Democrat and the Republican.
Yes.
Okay.
If you would go back to the app, I think it would be nice to show them one of the options with the distributions where you can show the distribution of the counts.
Okay,
and,
good point.
And then you have the four distributions there, and students can see the relationship between the distribution of counts, the sampling distribution, which is just your binomial distribution, and then the sampling distribution of proportions. Yeah,
let me go back and maybe put in just n equals 50 again. That's more reasonable for students to think about. They might, proportions, that's sometimes they don't think in terms of proportion, they think in terms of the absolute numbers, the number of successes, right? And so there is an option to show, where is that? Show distribution of successes that will then show the exact same distribution just for the number of successes instead. And maybe that's initially for a student easy to understand. It's the same thing, right? It's the exact same shape. Here I'm just plotting the number of successes, and here I'm dividing the number of successes by the sample size by 50 to get the proportion of successes. But it's the exact same thing. And of course, what you can show in this plot is the approximation of the binomial distribution, which this is. The approximation of the binomial distribution by the normal distribution as your sample size, as I make the sample size larger and larger.
You do have one more question about the white bands between the histogram bars.
Yes, this is something I'm working on. I have to, unfortunately, define the bin sizes of these plots here. And then depending on your screen, the width of the screen you're selecting, you sometimes get these white bands. I yet haven't found a solution. The best thing is to just make your window, your browser window, a little bit bigger or a little bit smaller. That often helps. And if not, then I encourage you to zoom in. Then this will definitely go away. This only happens, right, if you have large sample sizes and there's so many bars to draw that these are ggplot graphs. They do something weird, and I haven't figured out the bug yet, why exactly that they do. It might just be not selecting the correct range. Any other questions? We go to the chat. I thought there's some, and please feel free to ask about any of the other apps, the Inference apps. There are resampling apps as well. If you want me to show them, I'm happy to. Yeah, so the white bands are an artifact, but the distribution is actually discrete. That's right. For small n, right, the sampling distribution is discrete of the sample proportions. There's only n+1 different outcomes for the sample proportion. So it's going to be a discrete distribution. This is, oh, somebody wrote this anyway, yes. So let's see, is there any app you want me to show in particular?
Does anyone have questions or want to see another app demonstrated?
Hey, Bernhard, I could mention if you want to show something very non-normal, if I remember correctly, I don't know if it's beyond the scope of what you want to do, but your permutation app for comparing two medians. For the dog's padding example, you get two peaks with a real trough right in the middle of the sampling distribution. It's
I see.
Showing that everything is approximately normal.
Okay, good. I'll go to this in a second. That just reminds me, Ellen, thanks for this one, to just show you another one that I really think is how we should teach the central limit theorem with an app. This is an app for the sampling distribution for the sample mean. And what you have here is real population distribution. I mentioned this before. So you get those weird kind of population distributions. This is, for instance, data on college depth, but what depth students graduate with. And this is really all colleges because of thanks to collegescorecard.com, right? We do have data on all colleges. So this really is a population distribution showing the average depth and the standard deviation. But you have other ones. I might have mentioned distances of New York taxi rides. So these are all, and this is more than 500,000 observations just on a particular day. This was December 1st, 2016. And here's the distances traveled by all those taxi rides on that day, a very skewed distribution. And now, right, if you think about just the central limit theorem, when does it kick in? Well, you could start, maybe just speed it up. With the sample size of 20, well, you're not quite normal yet, right? But for the sampling distribution of the sample mean, but see, you can explore here now. Well, 30, we often say is a cutoff. That's getting closer, but maybe this distribution is really skewed, very long right tail. And so you might have to have larger sample sizes for the distribution to be roughly normal. And then going back to Ellen's question, let me see, where are you meant the one for, let me think, this was about the permutation ones.
Mm-hmm.
So there is an app for permutation test. I mostly focus, and I think the way we should teach, if you do teach the permutation test, the way to introduce it makes sense for 2 sample comparisons. So I have one for 2 samples. That's, I think, the example Ella mentioned. This is a small data set. 14 dogs were randomly assigned to either petting or to vocal praise. And then it was shown how long it took for the dog to interact with the owner. If the owner provides petting or vocal praise, and I forgot exactly the details now of this example, but here's the distribution, or here's the data, showing the data in a plot. And now what happens if I think we want to, maybe don't want to go for means, we want to go for median times, difference in the median interaction time. You see the sample medians here. What happens if I permute the data once? So I permute the data once, and then what this shows is sort of which of these green ones are now yellow and which of the yellows are greens as I flip them along. And in that permutation, and I think you can even show the permutation sample, right? You can show how these observations from the original groups are reassigned to the 2 groups. You can see that. If you click here one, and if you click on doing that, you sort of see those things. And if you speed up the simulation, then you might get a really interesting distribution for the difference between 2 medians, which I think this is what you want to show, Alan, right? Which is really bimodal. It's kind of unfortunate.
Mm-hmm.
But again, maybe if you just want to teach the concept of permutation, looking at this graph from the original sample and the permuted sample might help to see with very few observations what is going on. What do we mean by reshuffling and then redistributing to the 2 groups? And that reminds me, I put a lot of work into the Bootstrap apps. Maybe let's even do the one for 1 sample to find confidence intervals. If you want to use the Bootstrap, if you really have skewed distributions and you don't think the central limit theorem applies, then again, very similar setup. You have your values here. Here's the dot plot. I think these are just sugar values of some cereals. And suppose we're interested in a confidence interval for the average sugar content, then, let's not go for the mean, let's go for the median sugar content, which might be better here. You can draw Bootstrap samples, and again, it sort of highlights which observations were selected to be included in the Bootstrap sample, not at all, once, or even twice, or even more often. And here then you see the dot plot of the Bootstrap sample. And this should update, and you can sort of see how the Bootstrap median, the median of the Bootstrap sample, jumps around, and how it jumps around, that's kept track on down here. And then so you see slowly the Bootstrap distribution of the median build up as you interact with the app. And if you increase this to 10,000, you should see the Bootstrap distribution, which for small sample sizes like this looks very discrete. There are other examples where you can, I think where I have other more, think larger data sets, and then you do get nicer distributions for, I don't know how this, well, this not even doesn't turn out this well, but even the mean, yeah, if you think about the mean, the bootstrap distribution for the mean, you can get that here too. And here you see approximately normal. So there isn't any issue with the normal distribution assumption. All right.
Bernhard, someone mentioned that they really like the power, the types of errors app. Maybe you might just quickly demonstrate that or show everyone that app.
Definitely, yes. So for the Power app, I don't go too much in my interest stats. I don't go too much into Power, except explaining the relationship between type 1 and type 2 error and what affects the type 2 error. So there's a Power app. If you scroll all the way down to the Inference chapter, the confidence intervals, there's this concept, and there's one called errors and powers. It does actually compute power for both proportions and tests about means. And so it actually does compute the right power. You can just read it off what the power should be. But suppose you have, I don't know, let's make a nice example. Suppose the true population proportion. So now that's the null value. Sorry, the null value testing something is 0.5. Now I can get this slider to go to 0.5. Suppose that the null value testing the null hypothesis that population proportion is 0.5. And to introduce power, I try to do this first with a one-sided test. It's easier. You want to say the alternative hypothesis is that the true proportion is less than 0.5. And now let's actually select a value in the alternative hypothesis. Suppose it's I don't know, let's put it 0.4. So 0.4 is the true value of the proportion. Where do we see, first off, type 1 error, and where do we see type 2 error? Well, so you go to display the type 1 error. This is right, assuming the null hypothesis is true. So if you assume the null hypothesis is true, then you're assuming that p is equal to 0.5. So you're operating under this red curve. And if you click on type 1 error here, you see that you would reject the null hypothesis if you somewhere here, if your sample proportion is this cutoff or lower. And this area happens to be, I think, what did I select for alpha here, 5%. So 5%, that's the cutoff. Any sample proportion you get that's lower than this cutoff, the p-value would be smaller than 0.05, you would reject the null hypothesis. And so what I'm saying is, if you get a sample proportion that comes out in this area, we often call the rejection area, then you're going to reject the null hypothesis. And what's the likelihood of or if the null hypothesis is true, if you're under this red curve, how likely is this to happen? Well, that's exactly represented by this red area, which is the type 1 error, which we control at 5%. The type 2 error, on the other hand, is, remember, failing to reject. So we don't reject if we're above that cutoff. And so, but we need to actually figure out the type 2 error. We need to specify a particular value in the alternative, 0.4 here. And so this will be the type 2 error, this area here under the blue curve. And now what so you can actually you can read off the values and say, oh gosh, if I have a sample size of only 50, I'm never going to get that study approved because it only has 41% power, or the opposite of power, 59% type 2 error. No institutional review board is going to approve that study. If, however, I increase my sample size to, let's say, 100, look how the type 2 error shrinks, because the sampling distributions get smaller. And so maybe if I have, I maybe go all the way up to 200, if I have a sample size of 200, well, now my type 2 error is only 11%, and my study will have 89% power, so this will get approved. I can actually run that study, but I need to sample 200 persons, 200 people. Or if you go back to 50, whatever we had before, and say, well, actually 0.4, I really think the true value is closer to 0.3, so you move those over to 0.3, and now you see also that's affecting the type 2 error, right? If your true proportion is further away from what you hypothesize it is, that's good. You're going to be less likely to make a type 2 error, and that's demonstrated by just taking the slider and shifting it over, right? If the true proportion was 0.05, then you will never make a type 2 error. It's impossible, right? Almost never. 0% chance of a type 2 error. So you could do this for proportions. You could also do it for means if you want to. There's a second tab up here that does the same for means.
Well, does anyone have any further questions or comments? Anything you want to ask Bernhard? We're getting close to the end of our hour and I don't want to keep you too long. I think you've wowed everyone, Bernhard.
Well,
Just
thank you.
I think this is, don't tell Alan and Beth, but this is my favorite set of web apps now. So they're just, I've been using them with the work I do with two-year college faculty in California, and they're just really nice and great for teaching. So thank you for putting these together. We really appreciate it.
You're welcome. Yeah, glad you find them useful.
Well, I'm very partial to these apps. I admit that I'm very biased for these apps. They're wonderful to use in an intro stat course, but what I really like about them is that they can be used at other grade levels, not AP courses. I know many middle school teachers that are using some of the apps, especially the exploring data apps, random number apps, the concept apps. So I think that's what's wonderful about these apps are they're so accessible and can be used at different grade levels and in different courses.
Maybe one thing I could add is, you know, as we all teach online now, especially I do, it's so easy to make screenshots. Like you do something in class, but then just take a screenshot and then, you know, whatever documents you provide to your students, I use Jamboard. I just put this in, put it into Jamboard. I can even annotate whatever I've done. It's really easy because you have the electronic version of it. And you can ask students to include screenshots in homework, which I do a lot. Just, you know, when asked them to compute normal percentiles, so, well, give me a screenshot.
And they're so nice, and like you say, in terms of taking screenshots or copying graphs for reports, it's just really, really nice, Bernhard.
I just see one important comment, and this is about accessibility of the apps. RStudio and Shiny are working very hard right now to make those apps more accessible. There's nothing I can do because I'm using the prepackaged functions, but over the last 3 months, there's been a lot of work done on Shiny part to make all these things accessible. That means you can use now you know, screen readers and the right things for colorblind and for blind people to still work with those apps. And so I'll have to update them at some point, but that's coming. That's coming to make them accessible. Because I saw someone made a comment to that regard.
Yeah, that's something that there's been a big thing at our district talking about making sure you can use just the keyboard to move through. It doesn't have to use the mouse for the people who struggle with that.
Yes, and I don't know how, well, we'll see. I know all these slider inputs and select inputs, we call them all those drop-down menus and sliders, they will be accessible. That they're rolling that out right now as we speak.
Bernhard, I thought I'd also mention there is a Facebook page. If you're a big user of Facebook, there's a Facebook page.
So I have not been active on social media. I'm not a social media guy. I need to get more active. That Facebook page I haven't touched in I think a year or a year and a half. I need to provide updates. I constantly update those apps. I do have a YouTube channel now, and I think probably every other week I'm just posting a video. They're not scripted or anything. They're just I needed that for my class basically, so I did one. So you can follow that one, the YouTube channel.
I just posted it in the chat for you, the link.
Okay, yeah, oh, thanks. And so there's little videos of me working with the apps. I will eventually get to the Twitter and Facebook stuff to provide updates. So happy if you follow that one. That's one way to keep updated, but I just need to learn those tools a little bit more.
Well, Bernhard, thank you so much. This was a great presentation to have before the Christmas holidays, the Hanukkah holidays, and gives us lots to think about for the upcoming next semester school.
Great. Thank you. Thank you all for connecting and being interested.
And we will be back in contact. We'll about the January K through 12 chat, but I just want to wish everyone a happy holiday season. Stay safe from COVID and try to rest. I think all of you need time to recover over the holidays. All right, so long, everyone.
If you have feedback, you're welcome to email me. I'm always looking for feedback. If you need specific features, thank you.
Yes, Bernhard, you have, I have requested things and you have definitely given them to me. So thank you. And thank you in advance because I actually am using this a lot more this year. You're absolutely right. It's great. It's great for remote teaching.
Maybe one thing, because I have so many of you here, one thing I'm struggling with is R uses different definitions of quantiles and quartiles, and that seems to come up. And I think it's a nuisance. We really shouldn't be hung up on that one, how we define a quartile. But I get a lot of comments about, you know, the quartiles that the app shows are not the same that other software are showing or that textbooks are showing. And that's just, there are so many ways to define a median or the first quartile. And that's often an issue. And I quite don't know what to do about that. And R even has, I think, 7 options to define. When you use the quantile function in R, there's 7 options to define which particular quantiles function you want to use.
The only thing I had a question about is, and this is one that I've thought about a lot recently, and I don't know why. That's where my brain goes. When you have a box plot, and let's say you have outliers, and then there's the whisker end. What is that point called?
The fence, the upper fence. I think Chuki called it not the fence.
I don't think it is because
no. So no, it depends. If there's no outlier, right? It's the min or the max, the upper one, and it goes to the box plot. The way I've learned it, it goes to the largest observation that's just below the upper fence. That's what I should say.
Exactly. And so I've looked it up. There's some place that I looked up that called it the adjacent, the upper adjacent value or the something like that. Anyway, my students were confused because it's in the box plot. I think you do call it a fence.
Do I call it fence?
Really
okay,
it's not really.
It's an actual observation. Yeah.
Okay. But yeah, but it's great. And you've definitely given me a few more options that I've requested. There's one thing that I was thinking about today because I gave my students access to your site again today. There's no geometric.
Oh, distribution. Ah, I see. Good. If
I would like that.
Easy to
you know, in your spare time, Bernhard. You know.
Yes. Okay. Interesting. Yeah.
That would be really fun.
You have time to go to the geometric. That's great.
Yeah, it's part of the ASAK curriculum. So.
I see.
Yeah, in AP statistics, that's part of the curriculum. So students have to be familiar with the geometric distribution.
Yeah.
One I want to
otherwise, I love it. Thank you.
Is about bays, like a tree, and there should be nice ways to do a tree, to visualize, you know, a tree where you can put in, you know, sensitivity and specificity, and all those values, and you get out the right stuff and visually appealing. So that's something I'm trying to work on.
That would be really nice to have that.
Thank you again.
Okay.
Thank you.
I especially appreciate, I'm going to say, I appreciate your keeping them accessible, freely accessible, and to whether, no matter what book people are using or what, because so many places have limited resources, and it's just the fact that they're open to anyone to use is amazing. So that's much appreciated.
That will always stay that way. Yeah. I'm trying, but I've failed so far to get someone to program a true app for a cell phone, but I'm failing so far. I actually spent too much money already on it.
You have to wait for the iPhone 22, which is going to be 12 by 12.
Yeah. Well, I want it to be native and not that you don't have to connect to the internet. And that means it's called a native app. And I'm working on it, but it's going to take at least another year to realize that project. and a lot of money. Those developers cost a lot. But I think it would be nice maybe because all students do have cell phones now. I think that's pretty, you can rely on them having a cell phone. Not necessarily a data connection, but a cell phone.
Mhm.
So we'll see. All right. Thanks, everyone. Bye.
Bye.
Thank you. Bye.
Thank you very much.
Bye.
Thank you. Appreciate it.
So Chris,
Yes.
are we going to wait and schedule the next one in just in January?
Yeah, that's what I was thinking with the holidays,
Mhm.
that we should probably just wait until January.
Yeah, see when, see when people are back to thinking about things. So,
Yeah, who knows what the situation will be like in terms of schools and COVID
Yeah.
come January. So I was thinking maybe either like possibly the second Thursday in January. Most people would be back in school, or maybe the third Thursday.
mhm. Yeah, I think give people a chance to get back.
That's what I was thinking.
Yeah, second or third.
Mm-hmm.
We seem to have more people that, even though there was the request to move to the later hour, we seem to get more people coming at this time than the later time.
Yeah,
Of course,
I
we
think
tried the later time once, so.
I think so too. So maybe we'll keep it at this time and then discuss it again at the next meeting.
Yeah.
Okay.
All righty,
All right.
hang in there.
Same to you.
All right,
Bye-bye.
bye, Rebecca.
Bye.
Thank you both.
I don't understand what it's just like so slow.